Hello everyone. In this video we are going to talk about arrays and vectors. If you have more than one scalar to store, right, one single value, then arrays and vectors are the way to go. And a matrix is basically a two-dimensional array. So if you want to do anything that involves vectors, arrays, linear algebra, and so on, you need to watch this lecture. Now, there are two libraries that you need to add, not for basic arrays, but for the array class and for the vector class, which are include array and include vector. And when I get to them, I'll talk about them. So the basic arrays that we have in the standard library, they are very limited in terms of what we can do with them. And I would say we can do probably a bunch of things with them, but it's very hard. You have to code everything, okay? So what I have here is a function that accepts an array and then prints the contents or the entries of that array. And we have not talked about functions yet, but just want to tell you that all this function does, you pass to it an array and the length of the array, and it is going to print the content of it. It's not going to return anything, so that's why you see this void. Again, we have a separate video on functions. So the first thing we have is regular arrays. So here I'm saying I have an array and the size of it is 5 and the entries of it are all integer numbers. So that's the first thing you do when you want to define an array. You have to say the entries are of what type and then what is the size. So the compiler, basically C++ program and compiler actually will consider that much of memory ahead of time. So when you define the entries, it can basically store those numbers for you. So this is what we do. We declare the array and we provide the size right when we declare it, okay? Now this kind of array, we call it static array. And by static, it means the size of it cannot change and the type of it. So if we say it's 5 and it's integer, then we have to abide by the rules. Later, you cannot come and add a 6th entry or 7th entry or something, or make it a length 4 or length 3. So the size of static arrays in C++ is fixed. You cannot change that. And then here you can see that I'm adding or defining the entries one by one, and all arrays, as I told you in the strings, they start with an index of 0. So the very first entry is at location or index 0. The second one is at index 1, and the nth one is at location n-1. So here I'm saying the first entry is value 3, the second entry is 6, the third entry is -5 and -6 and 11. So I pass these 5 values and I form my array number 1, array 1, okay? So these are the important things. A static array, fixed size, you have to provide the size when you declare it, and then the index starts from 0. Now there is a second way that you can define a static array. How is that? Here you don't define a size, but right away after declaration you assign the values in a brace like this. In braces, you assign the values separated by comma. And you might say, what about the size? Didn't you say that you have to define the size? Well, in this case, because you are giving it all of the entries in one place, not in several lines of command, in one line of command, just where you declare it, the size, which is 5 entries here, is going to be what? It's going to be deduced. You don't need to provide it. If you give it all the numbers, then it will find, hey, I have 5 entries, so the size is 5. So there are two ways that you can define what? Static arrays. First, declare it with the size, then go and provide the numbers one by one, or declare it and assign it all the values in one single place, and here the size is not needed. It's going to find it by itself. Now, something that you cannot do is this. So you provide the size, okay, and then give all values in the single command like this. So if I go ahead and uncomment these two lines, so this one is none of those two, right? You see, I'm declaring and giving the size, and then instead of going one by one, I provide all the entries in the same place, right? Can I do that? And you're going to see that you get an error. And it says assigning to an array from an initializer's list. This is your initializer's list, and you're assigning all of it in one place to the vector that was already declared. That you cannot do. So keep that in mind. You're going to get an error for this. Okay, going back. So sometimes you declare an array and you give it some values, but not enough. So you say the array has 6 numbers, but you only provide 2 numbers. So what happens to the other 4 numbers? If you don't provide those numbers, C++ by default will pass all other numbers to be 0. So we call it padding. It pads these 1, 2 with 4 zeros to make the size what? 6. So just keep that in mind. If you provide more numbers than this size, you're going to get an error. If you provide less numbers, you're going to get a bunch of extra zeros. Okay? Now, what about a matrix? How do you define a matrix, which is a 2D array? This time, you have to provide 2 dimensions in 2 separate brackets. So you say this matrix has 3 rows and what? 2 columns. And then inside the braces, each row of the matrix is going to be defined by another set of braces. So the first row is 1, 2, the second row is 4, 3, the last row is what? 5 and 6. So it has 3 rows and what? 2 columns. So that's how you define a matrix in C++. In MATLAB, you use semicolon to go to the next row. In C++, you use a brace, okay, to define the content of each row. And once you close it and open another one, that's a new row. So that's how you define a matrix, and you can make it 3-dimensional matrix or something if you want. But for now, let's just skip it to 1D and 2D. Now, if I want to type values of one of these arrays or matrices, array 1, array 2, array 4, 3, or any of that, how do I do it? Well, of course, using indices. For example, if I want the first entry of array 2, which is basically what? 1. How do I do it? I say, hey, give me array 2, and in bracket, I say 0. Or this matrix, if I want the entry 1 and 1, what do I say? I say, give me array 3, what? 0 and 0. So here I can add them for you. This is what? This is entry 1 and 1, right? This is what? This is entry 1. When I say what? Array 4, 3, what does that mean? Place 3 is corresponding to entry number 4, because remember, place entry 1 is index 0. So entry 3 is what? Entry 4, basically. This is the 4th entry of array 4, which, as you can see, is going to be those padded zeros. So this guy is going to give me 0, this guy is going to give me 1, and array 2, 0 is also going to be what? 1. So the results of this printing is going to be 1, 1, and 0. So let's go ahead and run it. And that's what I told you. 1, 1, and what? 0. Okay? So accessing elements or entries of a matrix or an array using indices. Now, if I want to find the length of an array, so somebody gave me an array and asked me what's the size of it, right? For example, this array 2 has a size of 5, or array 1 has size of 5, or anything for that matter. Array 4 is 6. How do I find that size? Well, the command size of that we have in C++, that is not going to give you the number of entries. That is going to give you the number of bytes that in the memory is needed to store array 2. So it says so many bytes is needed or are needed to store what? To store array 2. Now, if I want to know how many entries are in array 2, what should I do? Well, I look at how many bytes you need for the whole thing and then divide it by how many bytes you need for what? for one of them, let's say array2 0, which is the first entry, and then divide, right? So if I need, let's say 32, or in this case is 5 times, let's say 4 bytes per each, right? Although it's integer, and integers, you know, it's 4 bytes, I assume. So 5 times 4 is 20. So you need 20 bytes to store this, and then the first one you need 4. So it's going to be 20 divided by 4. So the size of, or the number of entries should be what? 5. So the next number should be 5. Let's see. And that's what you see here. The length of array2 is what? 5. So if you want the command, if you want to find length, there is no command called length like you had in MATLAB. There is no command like that. And even size is not going to give you size for a matrix or something. You have to, what? Have to divide size of the whole storage divided by size of one entry to get the length. Okay, that's one of the disadvantages of simple static arrays, that there is no command like length or something. Okay, but I'll show you when we go to the class array or the class vector, there is a command that you can directly find the number of entries. What else? Now you might say, how can I show all of the contents of array2? Is there any way I can show all of the contents of array2? Right, which is basically 1, 2, 3, 4, 5. Can I print all of this array2 on the screen? And you might say, well, I just say cout and then array2 and end line, right? Show me array2 on the screen. Well, let's see what happens if you do that. So this is what you get. That's not this guy, it's this one. 0x61FD80, which is a memory address. So what is it returning for me? It's the memory address of the first entry in array2. That's how arrays are stored in memory. They are stored by the address of the memory of the first entry. Okay, that's what we call a pointer, and we'll talk about pointers in the future videos. Okay, so clearly this is not going to give me the content of that array2. You might say, well, I might be able to use the iterators that I showed you in strings. Can I use iterators? Can I use a for loop? And then go ahead and see the content. So I do this. I say for iterator, which starts from array beginning to array end, less than array end, go ahead and add to this iterator one at a time, and then show what? Show a space and then the content of that iterator. Because as I told you, these iterators, right, or the name of the array, they are all what we call a memory location. They are a memory address. So when I use a star memory address, that means the content. We're gonna talk about this in one of my future videos when we get to the pointers and the memory address. We'll see the two operators. One of them is the and the other one is asterisk. So this is the memory address and this is the content of that memory address. We'll get to them. But basically what I'm doing here is go to the first location, go to the memory home of the first location in array2, show the content of it, and keep adding to the memory location one at a time until you get to the end of that array2 and keep showing the content. So we expect this for loop to do what? Just like it did for the strings, to show me all the contents of this array2. But guess what? Look, you get an error. And it says, hey, for a static array, there is no command called .begin or .end. There is no method called .begin or .end because these are basic, simple, static arrays. They do not have these two guys. So you cannot use these two functions or these two commands, okay? So you see how much limitations you have. You want to see the contents, you cannot print them. You cannot use iterators. You want to see the length. There is no command for it. You have to do this division to do it, right? So in general, Static arrays, you want to resize it, you cannot resize it. There are too much limitations when you use what? The basic static array. Okay? So if that's not enough, I'll give you more limitations. One of the other limitations is if you want to pass an array to a function, like this function that we had on the top, let's say I just want to use this function to print the contents of that array for me. It's not just enough to pass the array. You also need to pass the length of the array to that function. Otherwise, that function is not going to be able to what? To operate. Okay, so that's another limitation that you have, that you cannot pass a whole array to a function as an input. What you can pass to it is a pointer, and that is this pointer here. As you can see, this is star, that is a pointer. Again, we'll talk about pointers later in details. All you can do is to pass a pointer to them, okay? And the important thing is, when arrays are passed to a function, a separate parameter, that is the length or the size of the array, has to be what? Has to be passed. When you pass vectors, that we're going to see in a minute, you don't need to do that. But for arrays, you need a pointer, which is the address of the array's first entry, as well as the length of the array. You pass both of them to any function that utilizes that array, then the function can work. And that is exactly what you can see here. I got the length of it by that division method, and then I passed the name of the array, which is a pointer, and the length of the array to this function array print. And what that function does is what? It takes that array, it takes that integer, it starts with the loop counter, and then it goes for I from 0 to length, go add 1 at a time, go ahead and show what? The array's content, okay? One number at a time. That's why when you run this content that you see you get from here, that is provided by this function. Okay, so you can use a function like this to what? To show the contents of a static array. So if somebody says, how would you show the content of a static array? You need something like this function. Okay? Okay, now is that all about arrays? Well, almost. There is one more thing I want to mention about the arrays, and remember I told you an array cannot be passed to a function as an input, but better than that, you cannot also return you see here this function main. Remember, this function main always has a return 0, right? You don't have to do it, it's optional, but you typically do. Now, can I have this function return for me an array 2, for example? Can I have this function returning an entire array back to me? The answer is no. The functions cannot accept an array as an input and cannot return an array as the output, okay? So that's the other thing we have, that the static vectors cannot be returned from a function unless they are dynamically declared. They are dynamic arrays. And then you might say, what is a dynamic array? And that's my next topic. What is a dynamic array? So far, the moral conclusion is this. Array operations using a standard library is extremely hard. You have to find a way around everything, right? They are not so flexible. You cannot do much with them, right? Without doing a lot of coding. So before I talk about class array and class vector, you might say, what is a dynamic array? And let me explain that one as well for you. Then we go to the next topic. The way that you define a dynamic array is, first of all, just like the other one, you have to say the type of it. You have to add this star to say it's a pointer variable. And basically, this pointer here is an integer, and is pointer to this vector of size 3, which has integer values. And to show that it's a dynamic array, you have the keyword new. So when you see the word new before an array, that means the array is dynamic. And this array, this ARR is what? Is the pointer to this dynamic array, and itself is an integer pointer. Again, we'll get to the pointers later. Don't worry too much about it. And here I go ahead and give it three entries, 2, 4, and -3. So I define the size of it 3, but the difference is for a dynamic array, I can go ahead and resize it. I can add something to it or remove something from it. I can change the size of it. Now, the changing size is not as simple as I add a fourth entry here, and say, hey, what? Array number 3 is equal to 6. I cannot do it this way. It's not that simple. Okay, so if I declare it 3 and then I make it size 4, that is not going to be that easy. Okay, so it's kind of a little bit trick to me personally than a legitimate, flexible, or dynamic thing. So the way that you do it is this. Here, you create a new, basically, array. Again, that guy is also what? A dynamic array. You can see new. And the size of this new one, let's say, is what? 4, because I want to add one extra entry. You want to go from size 3 to size 4. And what you do is you copy the content of the array that you had to this new array. And how much of memory's basically information would you copy? 3 times size of int, right? Because remember, the values inside array and array new, they are all integer. Size of new is 4 bytes or 32 bits. And this guy had 3 integer numbers in it. So 3 times 4, you're going to copy 12 bytes of memory information that was in array. You're going to copy it to what? To new array. This mem copy is exactly that one. So you copy the content of array into new array. Yes, and then the previous array, you're going to delete it. That's another thing about dynamic arrays. That when you are done using them and you don't want them anymore, you cannot just let them be. They are not going to be deleted by themselves. You have to manually delete them. So you say, hey, delete everything in that location array in the memory. And now what? Now this new array, whatever it is, go ahead and what? Go ahead and assign it back to this variable array. Why? Because I want my variable's name to be array, not new array. And now, guess what? This array has size 4. So I can give it a 4th value, just like you can see here. And now that I don't want new array anymore, I delete the new array as well. You have to use this guy. Okay, so basically this is like what? This is like, I have a container. Let me show you. So this is like, I have a container, and this container can hold what? 3 basically numbers in it, right? So all it can hold is 1, and then 2, and then 3. This is that array. Okay, this is what you had. Now I wanna what? I wanna squeeze one thing in, but it doesn't have the room. So what I do is I go ahead and create a new container which has what? Which has capacity of 4 entries, right? Something like this. And then I go ahead and copy the information into what? I copy the information from this array, copy them, and bring them all here. And then get rid of what? This array. This new guy, I call it what? Array new. And now what? I can add one more entry to this because this guy has capacity 4. Now, since I don't want the name of the variable to be array new, what do? I create a new variable called array, and I copy array new into array. I assign array new to array and then get rid of array new. Right? Do you see the process? How beautiful it is, right? It's basically, to me, it's just a trick. Well, just go ahead and all you need to do is, instead of all of this, go ahead and create a new array, right? Go ahead and delete that previous array or give it a new name, array1 or whatever you want, and give it these 4 values. And forget about all of this dynamic thing and deleting and everything. So if you want to resize a static vector, you better define a new variable with the size that you want and put everything in, instead of going through this trick of dynamic array. So to me, this idea of dynamic array is not such a beautiful idea, and I'm not personally a big fan of it, but just wanted to tell you about it. Now, when you're dealing with array, if you want flexibility and more options, I recommend, if you want to stick to arrays, at least use the class called array. The class called array, if you want to define any member from it, you use the keyword array, and then inside this bigger than less than, you provide the type of the entries and the size of the entry. Then you give it a name, and then you assign the variables, right? So this is an array of size 5 integers. Now the good thing is, if you want the size of this array called array temp, guess what? All you need to use is the command .size. That is going to give you exactly 5. If you want to see the content of it, you can easily use what? Array temp begin and array temp end. You can use iterators and you can see the content. You don't need an extra function for that. So this class array has a size function and it has iterators. Now, is that flexible? Can you add something to it? Is it dynamic? No, it's still a static. Okay, so it's not really static, but at least it has some of the limitations of this simple static array removed, right? At least you can get the size of it and you can show the content of it. This one, you couldn't do any of that. And in order to use this class array, you have to include the library array. Otherwise, it's not going to work. So you see here, when I run it, you see, it says what? The size of this static array is what? 5, and the class array, and the contents are 216, 77, 34, and 50, right? So that's what you will get. Okay. So let's go ahead and go, but there is one more thing, sorry. There's one more thing that I need to talk about. And that was about the dynamic array. I just forgot, I just saw it. One disadvantage of dynamic array is if you use the command size of to get the memory, the amount of memory that you need for a dynamic array, if you use the command size of, it's not going to give you the right size. Actually, the size of a dynamic array is not even stored and it cannot be accessed. So it's not like the static array that you could get the length of it, right? The length of a dynamic array you cannot get, right? So here, look. This guy has 3 entries and they're integers. So I expect 3 times 4, I need 12 bytes to store that. But when I run the command size of on this, instead of 12 bytes, look at what it gives me. It gives me 8, which is not right. So it's basically giving me what we can call a nonsense, really. It doesn't make any sense. So if you have a dynamic array, do not expect to get the length of it or the amount of memory for it. You cannot do that, okay? Just wanted to warn you about that. Good. So you might say, well, with all these limitations of array and something, what is the best option? The best option is vector. A vector is the best option, the most flexible option that you have in C++. In order to use vectors, you have to include the library vector. Now, what do you have here? You say the variable is a vector. You provide what? The type of the variables in it, and you give it a name. So you declare the variable. Then you start putting the numbers one by one, adding the numbers to the vector. And the way you do it is using this method called pushback, push_back. So you say, hey, first, for the first entry, go ahead and enter 10, then enter 20, then 30, then 40, then what? 50, right? So you start inserting the numbers one by one into the array. If you don't like to do it that way, you can do it by simply saying what? V is what? In braces, 10, 20, 30, 40, and 50. So how do you do that? Well, here, when you define the vector, then basically you define it by directly adding the numbers. So you do declaration as well as the assignment. Okay, so this one will do the exact same job for you, right? So if I do it this way, this is equivalent to that, and you might probably prefer it this way. But clearly it shows that here I'm constantly changing the size of the array, right? You see, when I didn't do it this way, the compiler didn't know I have 5 numbers. So first I said enter 10, so the size of vector becomes 1. Then add 20, so it becomes 2, 3, 4, 5. So I'm changing the size of vector one at a time. I'm increasing it, and it has no problem because vectors are flexible. Or as I said, I can do it in one command like this, and both of them will what? Will work. There will be no problem. So it's up to you, but here the goal here is to show you that I can insert anything that I want, and it is going to be added at the very end of the vector. So whatever number that you add is going to be added on the very right side, right? And then it keeps pushing to the left. So the number that was here will be pushed to the left, the number on the right will be pushed to the left, and then a new number is added on the right side. That's what the pushback does. So not only you can add entries, you can remove entries from a vector, and the command to do it is v.erase. So you say, hey, go to v.begin, so you see the iterators are also working. Go to v.begin, which is the first entry, plus 2, which is what? Now entry number 3. Go to, this is v.begin, this is v.end, the memory of it. Go to what? v.begin, v.end. So here is v.begin plus 2, which is this entry. Go to that entry and erase it. So v after this operation will be changed, will be altered, and the result is what? 10, 20, 40, and 50, and you just saw that. That's what it does here, right? So clearly v.pushback and v.erase are the way to add and remove. v.begin and v.end is to access the beginning and the end elements. If you want the size of the vector, all you need to pass is v.size, and that will easily what? Easily show the size of the vector for you. As you can see, the size is 4. And here, if you want to display the content of a vector, you still cannot say see out V. You cannot do that. It's not like MATLAB. You cannot pass an entire vector or an array as one variable and expect it to be what? Shown on the screen. What you need to do is a for loop. You have to show it one by one, but this is not a separate function. It's extremely easy. So you say for this auto x in V, this iterator basic or content, sorry, this is content. This content x, which is in V, go ahead and show that x and then add a space so the contents are like there is a space between them as you show them. Right? So as simple as this, you can show all of the contents of V. And that's what you just saw over here. Let me do that. You see here, if I do that, I'm going to get an error. Right? So this guy is what? This is going to produce an error. You cannot do that. Okay? But if you do it with the for loop, there is absolutely what? No problem. It does it without any issue. So you see how good the vectors are. Right? Very, very easily. Change the size of the vector by adding or removing. See the length of the vector. Show the content of the vector. If you want to pass it to a function like this, you do not need to pass what? The length as well. All you need to pass is that V alone. And a function can also what? Return a vector for you. When we get to the functions, I'll provide examples for that. So in general, vectors are way more preferred compared to arrays. And here I have summarized big differences between vectors and arrays, and I read them for you. Vector is a sequential container to store elements and not index-based, right? While arrays, they store a fixed size of sequential collection of elements of the same type, and it is index-based, right? So vectors, you have to access them by index and a fixed number of elements, while vectors, they are sequential based. So all it knows is after 10 comes 20, after 20 comes 30. It's not going to say, hey, 20 is entry number 1. 30 is index number 2, entry number 3, sorry. 20 is index number 2 or something. No. It knows that I had 10, now it's coming 20, then 30, then 40, and I can change that. Vector is dynamic in nature, right? And the size of it increases by insertion of element and is decreased by removing or erasing elements. Array is fixed size, and so it cannot be initialized. Once initialized, it cannot be resized, of course. Vectors occupy more memory. Arrays are more efficient. So that's the only reason you might prefer arrays. Arrays are more efficient in terms of memory than vectors. And also vectors take a little bit more time in accessing elements because there is no index. But arrays always can access their own entries a lot faster. So that index that you use in arrays is something good. It's something good. It makes the processing time and the memory a lot better, but at the same time, it makes everything harder and requires a lot more coding. So it depends on what you want to do. Do you care about time and memory, or do you care about the ease of programming? It's completely up to you. Arrays cannot be returned unless dynamically allocated, while vectors can easily be what? Returned from a function. And as I said, when I get to the functions lecture, I'll show you how to pass a vector to a function and return it from a function, okay? But for arrays, you cannot do that. So these are important differences. Hopefully this long video was useful to you, and I'll see you in my next lecture.